Alright, in this video we're going to talk about how to assign ionic charges in order to write formulas for compounds. So the first thing you have to know is how to be able to assign charges in the first place. So it gives you a lot of charges on your reference table, and usually it's just safe to use those. For elements that have multiple charges listed, you can just pick the top one on the list, not the highest value, but the value that's at the top of that list. So for nitrogen, if we have like -3 and -2 and all these values down there, just pick -3, it's the one at the top of the list. In other words, all those charges that are given to you on the periodic table are generally going to follow the octet rule for the best charge. So if we have group 1 and we look at sodium and potassium, if we take the neutral element and sodium and we make it sodium plus by giving it by taking an electron away, this would then give sodium the full octet. So all of these charge rules here are based on the octet rule. So remember, we to have 8 electrons around an element is really stable. So that's what all of these elements are going to form, is the most stable electron configuration by following the octet rule. So for group 1 elements, that would be +1. For group 2, it would be +2. For group 13 or group 3A, it would be +3. For group 16, it would generally be -2. For 17, the halogens, -1. Hydrogen usually has +1, but it can be -1 in certain compounds, but generally you should be looking for +1 for hydrogen. The transition metals vary, and those are based on the other ions in the compound to find those. So if we have copper with a bromine, and we know that bromine, being a halogen here, likes to have a -1 charge, then we could then figure out what the copper charge would be based on that, and that's kind of what we're going to do with this assigning charges today. So again, just kind of base all of your charges on the octet rule and see what would be the most favorable charge or oxidation state for the element based on the octet rule. So for polyatomic ions, remember those are in table E in your reference table. The charge is given to you there. So if we have, let's say, sulfate, sulfate is SO4 with a charge of -2. This charge is given to you straight off table E, so you don't even have to know any of the charges for these polyatomic ions. So again, polyatomic ions, just look off table E. Alright, so this is how we're going to write these formulas, is using this thing called the crossover rule. So what we're going to do is first assign a charge to each element. So if we take this example down here with sodium and sulfur, sodium, based on our charge rules, is going to like to have a +1 charge, and sulfur is going to like to have a -2 charge. These are the charges that would give both of these elements a full octet. So we're going to use those. Those are the most stable ionic configurations for these elements. So the second step is to crisscross the charges to find the subscripts. So we're going to basically take, if we have Na +1 and sulfur -2, we're just going to cross this charge down here to get the subscript for sulfur, which would be 1, and cross this one down here to get the subscript for sodium, which would be 2. Notice we're not going to take this negative sign down here, because what these subscripts tell us, remember, is that how many of each element we have. So this means we then have 2 sodiums and 1 sulfur, which we can't have a negative number of sodium atoms. That doesn't make any sense, right? So we're never going to take these negative signs down with us when we cross the subscripts, or when we cross the charges down to get the subscripts. And the last thing here that's very important to know is that the charges of an ionic compound have to add up to 0. So that's basically why we're doing this crossover rule. That's the point of it, is we're seeing how many of each element do we need in order to make the charges add up to 0. So then if we look here, we have a sodium, which is +1, and we have 2 of them now. So we have +1, +1, and then sulfur, we have 1 of those, and they're each -2. So -2. If we add all these charges up, that will give us 0. We have 1, 1, and -2. That gives us a total of 0. So you can see kind of that's what the crossover rule does for us, is it says how can we make these charges add up to 0, and it gives you a little mathematical trick to get that. So if we were to write this formula out properly, it would be Na2S, because again, we don't write these 1s in the subscript. So you can kind of cross it down just to show your work and make sure that you added the charges up right. But remember, when we write our final formulas, we never write 1s in the subscript. If there's no subscript, it's implied as a 1. Alright, so if we look at another example here between calcium and chlorine, using our charge rules, calcium is in group 2, so it's going to have Ca plus 2, and chlorine is a halogen, it's going to have a -1 charge. So to find the formula here, we're just going to cross these charges down, so we get 2 here, and then a 1 here. So this is going to be CaCl2 as our final formula here. So again, we just take the charge of each element using our charge rules. You can just look these up in the periodic table really, and then cross them down to get the subscripts. So the 2 from the calcium comes down here as the subscript for the chlorine, and the 1 for the chlorine comes down here as the subscript for the calcium. Again, we don't write the 1s in this formula, so calcium chloride CaCl2 would be our final answer here. So here we've got a polyatomic ion. This is ammonium and oxygen. So the polyatomic ion, just straight off table S, we already know it has this +1 charge, so we say NH4 plus 1. And then we have oxygen, which has a -2 charge. We could look that up in the periodic table, but also this would be the most favorable charge based on the octet rule. So we have oxygen -2. If we were to cross these down, we would get 2 here, and then 1 here. So the final formula here would be NH4 2O. Again, we don't write this 1. So a little note here, whenever you add a subscript here to a polyatomic ion like we did, we have NH4 plus, which is a polyatomic ion, and we're adding a subscript to that. Whenever you add a subscript to a polyatomic, you have to add parentheses around the polyatomic. So if it's not polyatomic, like in the last example we had CaCl2, there are no parentheses necessary here because the chlorine is not a polyatomic ion, it's just one element. The NH4, on the other hand, the ammonium, is a polyatomic ion, so therefore we have to add parentheses whenever we add a subscript. If you're not adding a subscript, let's say we had NH4 plus and maybe Cl. So NH4 has a +1 charge, Cl has a -1 charge. If we cross these down, we get 1 and 1. So remember, we don't write the 1s. This would just be NH4 Cl as our final formula. So because we didn't add any subscript, there's no parentheses necessary here. The parentheses are only necessary if we're adding a subscript like this to the polyatomic ion. So what that shows basically is that if we say NH4 2, this would kind of, this is just not proper form for writing a chemical formula, but this would indicate that the 2 applies to the hydrogen but not to the nitrogen. So by including the parentheses, we're basically showing distribution of this subscript to both elements in the compound. So this would give us a total of 8 hydrogens and 2 nitrogens, or in other words, 2 ammonium ions total. Alright, so another example here, we have boron and sulfate. So looking at our charge rules, boron over there in group 13 likes to have a +3 charge. So if we say boron +3, and then sulfate, which has a -2 charge, or sorry, this was 3. So to get the formula here, we're just going to cross these down. We get a 2 down here and a 3 down here. So our final formula is going to be B2 and then parentheses SO4 3. So again, because we're adding a subscript here to this polyatomic ion, then we need to add the parentheses to the polyatomic to make sure that this 3 we know is applying to the whole ion and not just this oxygen. So again, here we just take the charges of each ion and then cross them down to get the subscripts for the other one. Alright, so one last example here. We've got aluminum and selenium. So selenium over there in the same group as oxygen has a -2 charge, and aluminum has a +3 charge. So we take aluminum +3 and selenium -2. We cross the charges down and we get 2 and 3 for our subscripts, so the final formula here would be Al2Se3. Alright, so again, to sum up the crossover rule, we're going to assign charges to each element and then cross them down to the opposite element in the compound to get the subscripts, and then write out our final formula using those subscripts. Thank you.